Hi class, welcome back. In this video, we're going to continue our introduction to structural equation modeling. Before we start, it's important to understand the role of statistics in social and behavioral research. Most likely, you have a research objective which help you to define the target population that you are interested in. From the target population, you select your sample. Ideally, the sample need to be random sample that is representative of the population. But in reality, it is infeasible to get randomly selected samples in most studies. Let's see, you collect the data you need from the sample, and statistics is a tool that helps you to describes variables in your dataset and make inferences about the population based on probability theories. So when you take statistical courses, you are actually building your statistical toolbox. For example, you have ANOVA, regression, and each of the procedures you learn, they serve different purpose or different functions. And you will pick the right statistical procedure for your data analysis based on your research question and the type of data you have. So structural equation modeling will be a new tool in your statistical toolbox. SEM is used to evaluate causal relationships between two or more variables with a linear equation system. We all know that correlation does not imply causation. We have to establish a causal relationship by meeting at least three conditions. Okay, the cause take place before the effect, and confounding variables or rival hypotheses have to be removed. And the only purpose that statistics can serve is to establish the variable association. Statistically, there is a significant relationship between the cause and the effect. Because of the variable association we observed, it is reasonable to argue that under the right circumstances, if you have causation between two variables, you should observe some correlation. So this is how SEM approaches causal relationships. As a researcher, you identify the variables you're interested in and propose the causal relationships among the variables based on literature and empirical evidence. The correlation between the variables in your collected data set should confirm the model you proposed if the causal relationships are theoretically sound. Let's look at example. Here, if I am interested in the job satisfaction in an organization, based on my research interest and the related literature, I identified 4 factors that has impact on job satisfaction in an organization. They are achievement, motivation, self-esteem, verbal intelligence, and performance. And the literature also just suggests that achievement, performance, and verbal intelligence are the 3 factors that have direct impact on job satisfaction, while self-esteem impacts job satisfaction through performance. And I present my final hypothesized model in a diagram like this. So you complete the first step, that is your model specification. Keep in mind that in SEM, the oval shape is used to represent latent factors that cannot be observed or measured directly. So for the 5 latent factors, we need to identify their indicators, that measurable indicators, to quantify those factors. You can see here I used two measured variables to indicate achievement motivation, self-esteem, and job satisfaction. And for the other two, verbal intelligence and performance, I only have one measurable indicator for each, with the lines that show the relationships between the variables. I actually already specified the parameters of the conceptual model we just proposed. Because SEM is one of the linear modeling techniques, the variables you choose to measure the latent factors are better to be continuous variables, but sometimes you can include dichotomous variables in a SEM model. Okay, let's see. We collected the data we needed from the sample we collected, and the variables in the dataset can be used to create a correlation matrix, which is called the observed matrix because the matrix was generated from the data you collected. In the meanwhile, another matrix can be created, which is based on the variable relationships you proposed in your model. That's why it's called model-implied matrix. Here you can see the correlation matrix that's from the observed data, the observed matrix. For example, the correlation between performance and the first indicator of job satisfaction is 0.418, so on and so forth. And also you can see the standard deviation for all the variables in the dataset. Now, the rationale is that the observed matrix and the model implied matrix should be equal or as close as possible to each other. With that, when you make those two comparable, you can estimate the values of the parameters. So once you have a model that with all the estimate values for the parameters, you can actually compare the observed matrix with the model implied matrix, see how well or how close they are to each other, and that's called the goodness of fit. Let's say we are lucky enough to end up with a model that shows satisfying goodness of fit indices. The relationships among the variables can be summarized using structural equations like this. They are just actually regression equations, and we'll talk about this in details later in the semester. Well, if we have a model that the fit indices are not that good, we actually can improve. All right, that is a quick overview of the SEM process. We start with model conceptualization. We identify the model parameters, then use the collected data to estimate the parameters. And with all the information, we can compare the observed matrix with the model implied matrix, see how well the model implied or the proposed model fit the real data. Okay, if necessary, we can modify the models to improve the fit indices. Okay, by now I hope you got the idea. So SEM is only a statistical procedure. By itself, there's no way we can make argument about causal relationships. However, if you can propose a model in which all the causal relationships between variables are supported by the theoretical or empirical evidence from the literature, we can use SEM as a tool to provide confirmation that the causal relationships are supported by the data. And that's why we said SEM takes a confirmatory approach to analyzing a structural model that specifies a theory-driven causal process. All right, we just got a very general overview of SEM as a procedure to establish causal modeling. We have a lot of details to explore, and we have a whole semester to do it. So thank you very much. I'll see you later.